is has allowed NISMED to develop the K-12 Science Curriculum Guide. The grades 7 and 8 learners modules and teachers guides were written mostly by NISMED specialists. As a result, NISMED likewise designed and conducted the training of trainers for both grade levels. Currently, NISMED serves as convener or consultant to the K-12 science curriculum. Among NISMED's initiatives is KaSaMa Teachers, which is an online community of Filipino science and mathematics educators. As you already know, membership is free, and KaSaMa Teachers supports NISMED's continuing work in K-12 science. When you visit the site, you will see discussions and discussion threads on K-12 science. You can also find links to the learners modules and teachers guides, and even download the latest DepEd issuances on K-12 program. Let's go to the webinar proper. Why is NISMED doing the webinars and what it is for? UP NISMED cannot train all grades 7 and 8 science teachers, but with technology, we can reach many. Hence, the webinar series. The webinars are free and are aimed to support teachers, schools, divisions, and even teacher education institutions in their implementation of the K-12 science curriculum reform. NISMED has partnered for this initiative with Intel Education for the free use of their webinar platform. Well, actually, participation in the live webinar is easy. Teachers just go to the webinar site every 4th Friday at 4 p.m. And if they miss a webinar, the recorded webinar as well as the presentations and documents shared during the webinar are all accessible in KaSaMa Teachers. The discussions and sharing of practices also continue in KaSaMa Teachers. So we would like again to welcome everyone to the 8th webinar in the series. The topic focuses on the overview of grade 8 science, and also our writers from NISMED will give you some facilitation tips for Unit 1, Force, Motion, and Energy. And for our agenda, we will have two main groups of presentations. The first one will be an overview of grade 8 science curriculum, and another one will focus on Unit 1, Force, Motion, and Energy, and we will be tackling 3 module presentations, one for Module 1, Module 2, and Module 4. And towards the end of these presentations, we will have one biology teacher, biology staff from UP NISMED, who will share his insights on the connection between physics and biology, or making the teaching of physics not so difficult for biology majors. And then we will have about 10 minutes of question and answer session. At this point, may I inform everyone that while the presentation is going on, you may type in your questions in the chat window, and we will collect them, copy all of them, and we will have later on opportunity to discuss answers to your questions during the Q&A session. And then after the Q&A session, we will have time to collect your feedback about the webinar, and we will also give you some announcements about the latest events in UP NISMED and also in KaSaMa Teachers. And then we wrap up, and hopefully we end up at 5:30 or a little later. So let me at this point switch to the presentation proper. Ladies and gentlemen, we are ready for the presentation. Alright, I'm loading now the first presentation, and let me take this opportunity to introduce our presenters this afternoon. Our first presenter is Dr. Marlene Ferido. Dr. Marlene Ferido is currently chair of the chemistry group of the University of UP NISMED. She also acts as consultant to the DepEd's K-12 basic education program for science. Dr. Ferido has also presented last year during our first year of the webinar series about the science curriculum along with Dr. Marlene. We are seeing more people coming in to join us. Alright, so today Dr. Ferido will walk us through grade 8 science curriculum and show us the connections between grade 7 science, the current grade 8 curriculum, and how it prepares students for the coming grade 9 science curriculum. Ladies and gentlemen, we are very proud to have with us this afternoon Dr. Marlene Ferido. Dr. Mar?
Good afternoon, everyone. Welcome to our 8th webinar on KaSaMa teachers. Before I go through the grade 8 science curriculum, I'd like to refresh you of the aim of science education, which is part, of course, of the science curriculum. It is to develop scientific literacy among students that will prepare them to be informed and participative citizens who are able to make judgments that may have social, health, or environmental impact. So this is what we'd like to see at the end of grade 12, and even as our students engage in whatever career they decide to have for their lifelong service. The science curriculum is constructed around the development of scientifically, technologically, and environmentally literate Filipinos who are critical problem solvers, responsible stewards of nature, innovative and creative citizens, informed decision makers, and effective communicators. In fact, these are mainly 21st century skills also. The science curriculum is also designed around what we call 3 domains of learning science. The first component is the inquiry skills. We'd like to develop inquiry skills among our students from grade 3 up to the time that they graduate from senior high school. The second component of the curriculum involves understanding and applying scientific knowledge. These are the content and connections. The third component, which is very essential also, is the development and demonstration of scientific attitudes and values, or what we call the habits of mind. The science K-12 curriculum has 3 important salient features. One, it is learner-centered. That means that the curriculum provides opportunities to create learning environments that will optimize learning and allow learners to think well and apply principles to new situations they are faced in real life. Secondly, it is inquiry-based. And thirdly, it shows spiral progression. Scientific inquiry is focused on proposing explanations for observations about the world around us. So this is the way these skills are developed among the children. They start at the elementary level with the simple process skills of observing, inferring, communicating, and classifying, on to more essential skills like designing simple investigations using appropriate procedures, materials, and tools to gather evidence, determining relationships, and drawing conclusions based on evidence. By the end of grade 10, aside from these process skills and intermediate or higher order thinking skills, the science curriculum aims to develop among the students the skill of really finding or doing investigations related to real life, with the emphasis that they recognize the central feature of an investigation, which is that when one variable is changed while controlling all others, the effect of the change on another variable can be measured. As the National Science Education Standards of the United States says, inquiry into authentic questions generated from student experiences is the central strategy for teaching science. Inquiry-based science teaching also enables our students to ask questions and use evidence to answer them. It enables them to conduct an investigation, not only for joining contests and competitions, but rather to be honed in collecting evidence from a variety of sources. It will enable students also to develop explanations from data gathered and communicate and defend their conclusions based on data. Now, the third important feature of the science curriculum in the K-12 is spiral progression approach. This is really a metaphor of a spiral where the scope and sequence of the content are developed such that concepts and skills are revisited at each grade level with increasing depth. The examples that will follow will show this. Progression is not only vertical, meaning it gets more complex, but it is also horizontal, meaning it has, the concepts have broader ranges of applications. Now, this is how the science content is organized from grade 3 to grade 10. There are 4 important strands called living things and their environment, force, motion, and energy. The third is matter, and the fourth is earth and space. Each of the strands have major themes. For living things and their environment, the themes are characteristics, structure and function, processes, and interactions. For force, motion, and energy, there's movement, effects of force, forms of energy, and transformation. For matter, there are only 3 themes: properties and structure, changes, interactions. And for earth and space, for geology, we have land, water, air. For meteorology, weather and climate. And for astronomy, the solar system. Now, the sequence of these strands vary from grade to grade as it is shown in the curriculum guide. Now, how was the science content organized, or what were the criteria used by the framers to place them in specific grade levels. The following are the criteria in prioritizing content and placement. 1. It goes from the macroscopic, meaning the visible, to microscopic. It goes from simple concepts to more complex concepts. Second, the placement considers appropriateness to the cognitive level of learners. That is why concepts of atoms and molecules are not taken up at the elementary level, but rather in grade 8 up to grade 10. Thirdly, the suitability to the cognitive level demand of the topic. There are concepts which are very difficult in terms of being understood by students. So they are placed at the high school level rather than at the elementary level. Fourthly, the prerequisites to succeeding topics and concepts are, of course, placed at the earlier years of schooling and builds up until these concepts are expanded with broader applications. Another important consideration is the alignment with mathematics skills. It was made sure that basic math skills, for example, graphing, have already been taken before being used and applied in activities for science, the building up of science concepts. And of course, lastly, all the placements have also considered what research has said, especially on clarifying or correcting misconceptions. Now, the development of ideas at the elementary level until grade 7 basically is focused on the macroscopic, the clearly observable in terms of the senses, and concrete situations and events. And students have numerous hands-on experiences. Also, concepts were encountered by the students in the context and life situations that they were most familiar with. And lastly, the focus is more on the tangible and visible. And research tells us that this approach is how science concepts should be taught initially. Now, in the arrangement of the strands in grade 7, you notice that the first quarter is matter, goes to living things and their environment, then force, motion, and energy, and earth and space in the last quarter. However, for grade 8, the sequence is different. You have force, motion, and energy for the first quarter, earth and space for the second, matter for the third and fourth, living things and their environment. Basically, this arrangement is also based on the criteria that I have earlier said, and also the prerequisite concepts that students need. In grade 7, the focus really also was on diversity. Diversity of matter and the diversity of living things and their environment. Now, what makes them diverse and also interact are forces, motion, and energy. And the last is to be able to appreciate what is on Earth and beyond. Concepts about matter, about living things, and energy and motion are essential to let the students appreciate all of what is on Earth and space. For grade 8, we have the strands delving already into what is microscopic and submicroscopic. In other words, students need to appreciate first how force, motion, and energy are important factors in understanding concepts about Earth and space. And while looking at this very big Earth and even beyond, they also have to go to the tiniest particle, which is the atom, related to the strand on matter. And also they begin to learn the tiniest also in terms of living things, which is the cell. Now, let me now go to the development of each strand in terms of the concepts covered. I will not focus much on force, motion, and energy, since the next presentation will be dealing with all these concepts for grade 7 and 8. Now, let me go to Earth and space. In grade 7, it was very important to emphasize the Philippine environment, the location of the Philippines using a coordinate system. This is the foundation in appreciating the subsequent topics covered for Earth and space. Also in grade 7, they learned about interactions in the atmosphere with respect to meteorology, the seasons in the Philippines, and they begin to enjoy the eclipses and the explanations behind them. In grade 8, the students learn about how active faults generate earthquakes. They learn about tsunamis, how tropical cyclones originate from warm ocean waters, and they also recognize other members of the solar system. You will see that it was very important in grade 7, they learned the location of the Philippines, because in grade 8, they will appreciate why these active faults in the Philippines generate earthquakes. Also, even our location with respect to the Pacific Ocean will explain how these tropical cyclones originate from the warm ocean waters. So, if you will look at the spiraling of concepts about Earth and space from grade 7 to grade 9, you will appreciate, and students will appreciate, that the Philippines is prone to earthquakes because we are located along the Ring of Fire. And that idea leads also to the concept elaborated in grade 9, why the Philippines is home to many volcanoes. Using models, which is an approach that is very common in science, in grade 8, students will explain how quakes are generated by faults. Of course, we cannot look at the active faults as they are, but we can use models to explain how quakes are generated. Also, models are used to explain what happens when volcanoes erupt in grade 9. And so, with all of this, I hope you see the development of the concepts gradually from grade 7 to 9 with respect to geology. Now, going to meteorology, in grade 7, now they have understood what ITCC mean, the Intertropical Convergence Zone, which they often hear from weather forecasts or weather reports. Now, this is related to the location of the Philippines with respect to the equator. That is why they have to learn a coordinate system and locate where the Philippines is. Now, being located beside the Pacific Ocean, Then the Philippines is prone to typhoons, and they learn that in grade 8. Then also in grade 9, they will distinguish weather from climate. Most often, you may have encountered elementary science textbooks which distinguish weather from climate. Now, in grade 9, in the K-12 curriculum, they will be able to explain how different factors affect the climate of an area. And they will also be introduced to climatic phenomena such as El Nino and global warming. Two phenomena which are oftentimes explained with numerous misconceptions. Going to astronomy, the grade 7 curriculum in science deals with an explanation of the seasons and eclipses as a result of the motions of the Earth and the Moon. Again, models are used in which students learn how to explain the revolution of the Earth around the Sun, the seasons, why the seasons change, and the revolution of the Moon around the Earth. Now, in grade 8, the focus will be on a survey of the solar system by describing characteristics of asteroids, comets, and other members of the solar system. Now, in grade 9, they leave the solar system, they go beyond, and they study the stars. They infer the characteristics of stars based on the characteristics of the sun. Again, models are used to show that constellations move in the course of a night because of the Earth's rotation. So you see that the strand on Earth and space is taught basically using models, because these are very big, in terms of hands-on experiences, it is beyond the scope of a classroom. Going to the strand on matter, in grade 7, the focus was doing scientific investigations or ways of acquiring knowledge. The students went through doing fully guided, semi-guided, and open-ended investigations. Of course, gradually. Then, the context of the investigations taken or studied in grade 7 includes the topics covered in grade 7 too, meaning solutions, substances and mixtures, elements and compounds, acids and bases, metals and non-metals. So here, they distinguish these different properties of solutions, which are homogeneous mixtures. However, in grade 9 already deals with a model. Again, this is a different model from that in Earth and space, but a model of the particles of matter to explain their behavior. They cannot see atoms, so a model has to be presented. And they will also realize now and appreciate that the smallest particle, of course, is the atom. They are very small, too small to be seen through a microscope. And so whatever properties they have learned in the earlier grades can now be explained by the types of particles involved in whatever material they're studying. They also study the atomic structure, and they begin to be familiar with the periodic table of elements, just as an organizational tool in arranging different types of materials or the different types or forms of matter. Here is the spiraling. Now going to grade 9, once they already know about the particle model of matter, they will use their understanding of atomic structure and they will describe how atoms form units called molecules. They will also explain how they bond or how they form these bonds with other atoms by either transferring or sharing electrons. They will realize that the forces that hold metals together are caused by the attraction between flowing electrons and positively charged metal ions. They already are familiar with this when they have taken forces, motion, and energy in grade 8, especially on the topic heat. Now, also in grade 9, they begin to appreciate that the carbon element forms a variety of compounds because of the kind of bonding that it exhibits. They also recognize that since matter consists of a very large number of very small particles, then counting is not practical. So this is the only time they are introduced to the concept of mole, not in grade 7. Then, another big theme on matter are the changes that materials undergo. From grade 7, they see the combination of materials in various ways and different processes, which lends to the diversity of materials. Now, they begin to classify this as elements and compounds, metals and nonmetals, acids and bases. Now, in grade 8, they have to realize that particles are always in motion. That's why the common changes that they observe around them, like changes from solid to liquid, solid to gas, liquid to solid, liquid to gas, they all involve changes in the motion of the particles and changes in the relative distances between these tiny particles, as well as attraction between them. Then when they reach grade 9, they will appreciate why these new compounds form, and these compounds are formed because the particles rearranged. They rearranged because they learned in grade 8 that they are in constant motion and there are distances between them. So let me now go to the next strand, which is living things and their environment. You recognize this as biology, but in the curriculum, it is described as living things and their environment. In grade 7, one of the most important tools that the student should learn is the way is how to use the microscope. So the first portion of grade 7 deals about the use of the microscope. Then, in terms of parts and function, there are levels of organization of living things, so that is introduced in grade 7, and zeroes in on the asexual and sexual reproduction in plants, and then goes microscopic to introduce what cells are in humans, animals, and plants, and how they vary from each other. In grade 8, the themes or the major themes for living things is biodiversity, which they already appreciated from grade 7, the diversity of species living in an ecosystem. Also, there are interactions which explain the food chain in an ecosystem. And grade 8 zeroes in on the digestive system and how enzymes affect digestion. And the students will be able to appreciate the action of these enzymes in the digestive system because in the third quarter, they've learned about particles of matter. Also, they will be introduced to cellular reproduction and genetics in grade 8. So you see here that in grade 8, because they already know about atoms and a little about molecules, they will learn and appreciate how the human body breaks down food into forms that can be absorbed through the digestive system and how they are transported to cells. Then also in grade 8, the students will learn that the gases exchanged to the respiratory system provides oxygen needed by the cells to release the energy stored in food. Now, oxygen is more appreciated because they have already studied this in the third quarter when they encountered the periodic table. Also, they will learn that dissolved wastes are removed to the urinary system, solid wastes are eliminated through the excretory system. Then in grade 9, they will have a more integrated and coordinated view of the functions of three systems, the digestive, respiratory, and circulatory. They will also learn that nutrients enter the bloodstream. So they appreciate this also because they already learned about ions in the earlier quarter of grade 9 when they talked about it under the strand of matter. So this is how the concepts are developed across the different strands and even within a strand. And then for heredity, which focuses on inheritance and variation, in grade 7, after they have learned about how flowering and non-flowering plants are produced, they also learn that asexual reproduction results in genetically identical offspring, whereas sexual reproduction gives rise to variation. Now, a deeper and a better appreciation of this will be elaborated when they learn the process of cell division by mitosis and meiosis. And they will understand that meiosis is an early step in sexual reproduction that leads to variation. When they get to grade 9, they go deeper by learning the structure of genes and chromosomes. Now, they can better appreciate the structure because in the earlier part of grade 9 on matter, they already learned about chemical bonding. And so, the functions of these genes and chromosomes as they perform in the transmission of traits from parents to offspring will be better appreciated. Now, in terms of biodiversity and evolution, because they know that there is variation, then of course, students in grade 8 will learn that species refers to a group of organisms that can mate with one another to produce fertile offsprings. Now, they will learn that biodiversity is a collective variety of species living in an ecosystem. Now, this is an introduction on the hierarchical taxonomic system that they will learn at the higher grade level. That it is very important, this is a central idea in grade 9, that most species that have once existed are now extinct because the environment has changed and these species have failed to adapt. So, looking at the entirety of all the strands, they connect with each other, and most of the concepts that are prerequisite to understanding the broader and the deeper concepts at the higher grade levels are dealt with in grade 7 and even at the elementary level. Now, going broader, they go and study ecosystems. They learn in grade 7 that there are interactions at different levels of organization. Then they learn about populations. Now in grade 8, they learn how energy is transformed and how materials are cycled or returned in the ecosystems. Now, they have enough foundation to know about energy because in the first quarter, they already learned about force, motion, and energy. I hope that you see as teachers the importance of taking force, motion, and energy in the first quarter. Now, in grade 9, with all of these concepts, interactions, ideas learned, now students can better appreciate how plants capture energy from the sun and store energy in sugar molecules during photosynthesis. And this stored energy is used by cells during cellular respiration. You will realize that in the old curriculum, this is taken in grade 8, all throughout grade 8, but the essential prerequisite concepts from force, motion, energy, from the particle nature of matter are not yet taken up. So with this, you see the whole storyline of grade 8 connecting with grade 7 and looking forward to the broader and deeper concepts of grade 9 and ultimately in grade 10. Hopefully, those who will go to the science, technology, and engineering track will have a better foundation of the basic concepts of science. I think this is my last slide. So thank you and hear from you during the Q&A.
Okay, maraming salamat, Dr. Ferido. Indeed, for K to 12, it is essential that we make sense of how concepts spiral, not just across the grade levels, but also across themes within and across each discipline. Once again, maraming salamat, Dr. Ferido. And folks, please don't hesitate, don't be shy. Type in your questions using the chat pad, and we are going to collect them later on for the question and answer. So far, we have a comment and one question from our participants at this point, Dr. Mar. Let us now welcome our next presenter. Our next presenter is Miss May Ronda Chavez. Let me show her picture. Ayaw yatang mag-hide. May has completed her Bachelor of Science in Secondary Education major in Physics from Bicol University in Legazpi City. She also completed the course requirement for the Master of Science in Teaching, again, major in Physics, at the De La Salle University in Manila. Before joining NISMED in 1996, May has taught at the high school department of Divine Word College, Legazpi, also in Legazpi City. Currently, May is Science Education Specialist 1 at the Physics Education Group here at NISMED, where she takes part in various curriculum materials development, research, and teacher professional development initiatives at NISMED. Let me, at this point, load May's presentation. So meanwhile, while I'm doing that, you might want to fill out the attendance form. Simply click on the link that you see at the bottom of the presentation window. Click on that link to the webinar number 8 attendance form. Okay, in today's webinar, May is going to present the overview for Unit 1, which is Force, Motion, and Energy, and she will also walk us through Modules 1 and 2. Module 1 being the module on forces and motion, and Module 2 on work and energy. Okay, I need to show May's picture. There she is. Okay, so her presentation is loading right now. May is going to provide the overview for Unit 1, which is focused on physics, force, motion, and energy. And she will also provide us with tips for facilitating the learning activities in Module 1 on forces and motion. And then after this presentation, she will move on to the presentation for Module 2, Work and Energy. So, tuloy-tuloy pong magbibigay sa atin ng presentation si May.
Okay, so the Unit 1 of the Grade 8 learning materials is on force, motion, and energy. Okay, so this is the transition on the unit of force, motion, and energy. Yes.
We may have to wait a little for a little while for the presentation to appear on the participants' screens. All right, so we're ready. Okay, go ahead, May.
Okay. Okay, so this is the transition of the unit of force, motion, and energy from grade 7 to grade 8. In grade 7, students learned that the different forms of energy travel in different ways. Light and sound travel through waves, heat travel through moving or vibrating particles, and electrical energy through moving charges. Now in grade 8, they will deepen their understanding of energy. They will learn how energy affects and is affected by matter. They relate the observable changes to the energy of particles that make up matter. The unit has 6 modules. The first module is on forces and motion, followed by work and energy, heat, electricity, sound, and light. For forces and motion, the key question is, how do forces affect the motion of an object? For work and energy, how are work and energy related? For heat, how does heat affect matter? For electricity, what are the factors that affect the current in a circuit? For sounds, what are the factors that affect the speed of sound? And lastly, for colors of light, what properties of light explain the separation of colors in white light? As you can see on the key questions, all this topic deals with the effect of energy transfer and how energy transfer is affected by matter. The modules on force and motion and work and energy deal with the transfer of energy by applying force to large objects, while the modules on heat and electricity discuss changes in energy of the particles. Okay, I'm with the modules on heat and electricity. Okay. Discuss changes in energy of the particles of matter which accompany energy transfer. While the modules on sounds and light describe the interaction between waves and matter. Most of the lessons found in each module take off from the lessons covered in grade 7. And most of the topics in this module are dealt with qualitatively in order for students to have a basic understanding of the concepts. Some tasks include measurements and computations to illustrate the relationship among quantities. So let me now go to the first module, which is on force and motion. So in grade 3, the students learn how objects move and can be moved. And in grade 4, they learn to describe the effects of pushing and pulling on the motion, size, and shape of objects. In grade 5, they do some quantitative measurements. So they measure the distance traveled and time of travel using appropriate tools. In grade 6, they observe and describe the effects of gravity and friction on the motion of objects. In grade 7, they describe the motion of objects in one dimension. So now in grade 8, they explain the motion of object using laws of motion. And in grade 9, they will explain the motion of object using conservation law and analyzes motion of object in two dimensions. And lastly, in grade 10, they describe how forces by solids and fluids affect the strength, balance, and stability of objects. So this is the transition from grade 7 to grade 8. So in grade 7, they answer the question, how do objects move? So this time in grade 8, they will answer, why do objects move the way they do? Previously in grade 7, they learned that energy exists in different forms. That energy can be transferred from one object or place to another in different ways. And motion is a concrete manifestation that a body possesses energy. So these are the learning competencies. If you look at the curriculum guide, you can find that it is the same competencies written there. So the key question in this module are, do forces always result in motion? What are the conditions for an object to stay at rest, to keep moving at constant velocity, or to move with increasing velocity? And lastly, how is force related to acceleration? Based on some of studies, these are some of the misconceptions of students. 1. If an object stays at rest, there is no force acting on it. Second, an object continues to move at constant velocity because a constant force acts on it. If the speed of an object increases, its acceleration also increases. Objects move because they have a force. They stop when their force is already used up. Force seems to be a property of a material. Through this in this module, all these misconceptions will be addressed. So the lesson starts with about forces acting on objects at rest. There are two situations shown: a pen hung by a piece of string and a book at rest on top of the table. Ask your students to identify the forces acting on the pen and the book. They can draw an arrow to show the direction of force as well as the magnitude. Okay, so for the pen, there is the force exerted by the string on the pen, and we call it tension force. And another force is the pull of gravity. For the book, the force exerted by the table on the book is called normal force, and the other force is the pull of gravity. What causes these objects to stay at rest? This is answered by activity 2. So in activity 2, if two forces acting on an object are equally magnitude, they are considered as balanced forces. So through the activity, the students will learn that the pen as well as the book stays at rest because the forces acting on them are balanced. How about for unbalanced forces? A ball pushed gently on top of a table will stop rolling after some time. Why would it stop moving? Let your students identify the forces acting on the ball. We have the force of gravity and the normal force acting on the ball. But these two forces are balanced. There is another force acting on the horizontal line. This force is called friction. It is the force that acts between surfaces in contact with another. It slows down the motion of the ball. Since no one is continuously pushing the ball, there is no force to balance friction. So due to the unbalanced force, the object changes its state of motion. Hence we say it accelerates. When we say acceleration, it can be an increase or decrease in velocity. By the way, if you look at the curriculum guide, the concept of force of gravity and friction are taught in grade 6. Hence, the student should already be familiar with these two forces. So, more on unbalanced forces. Activity 3 is on investigating inertia. This activity demonstrates how the inertia of an object affects its motion. Before the students do the activity, ask them what they think will happen to the coin if they flick the cardboard. By flicking the cardboard, the coin will fall on the glass rather than going with the cardboard. So, they will learn in this activity that our body will remain at rest or move at constant velocity unless acted upon by an external net or unbalanced force. Next is on force and acceleration. If the students cannot perform the activity, for example, you don't have the ticker timer, sample data strips are available in the teaching guide. It is included in the teaching guide. So in this activity, the students will do some simple computations to get the value of average velocity and acceleration. In the activity, the students will find out that as the number of rubber bands increase, the acceleration of the cart also increases. They will arrive at the idea that at a constant mass, the acceleration of an object is directly proportional to the magnitude of the unbalanced force acting on it. Last one is on action and reaction forces. In the activity, the students will hook two spring balances and pull them apart. They will see that the readings on both spring balances are the same. The activity demonstrates the law of interaction, that for every action, there is an equal and opposite reaction. But this may cause confusion with balanced forces. So these are the action and reaction forces to balanced forces, which we discussed earlier. So for action-reaction forces, the two forces are equal in size. So the same with balanced forces, two forces are equal in size. And then it is also similar that the two forces are opposite to each other in terms of direction. And then the two forces have the same line of action. But for action-reaction forces, the action acts on one object while reaction acts on another object. While for balanced forces, the two forces act upon the same object. So these are the essential ideas that they will learn after the module. The Newton's laws relate the forces acting on an object to its motion. An object stays in its state of motion when the forces acting upon it are balanced. It changes its state of motion when the forces acting upon it are unbalanced. Then changes in the motion of an object depends on its mass and the amount and direction of the net force acting upon it. Okay, so that's all on Module 1.
Thank you again, May. This is the first part of May's presentation.
Yes, sir.
Sa Module 1, Forces and Motion. Ganun pala, no? Dapat unbalanced yung mga forces bago magkaroon ng motion. Hindi pala dahil hindi gumagalaw ay dahil walang force. Hindi pala, no? Pag balanse yung forces at opposite, hindi siya gagalaw. Tama ba yun, May? Tama ba yung aking intindi?
Yes, sir.
Okay, so I will now load May's presentation for Module 2 on work and energy. Sandali lang po. Again, those who just joined us, kindly fill up the attendance form by clicking on the link you find at the lower right of your screens. Okay, so Module 2. Alright, so loading the second presentation. Again, in this presentation, May is going to guide us through the concepts as they spiral from grade 7 to 8. And then also show us the setups for the different learning activities and provide some tips on how to facilitate those activities with students. And then finally summarize for us the essential concepts or ideas, key ideas in work and energy for grade 8 science. Okay, we're still loading the presentation. Yes, Lawrence Maravillas has asked if we're going to discuss Module 2. Yes, we're going to discuss Module 2. And I think we're ready for that right now. Okay, May, take it away. It's Module 2, Work and Energy with May Chavez again.
Okay na? Okay, so Module 2 is about work and energy.
Okay, May, we're ready.
As presented in Module 1 in grade 7. Yes, Sel. Okay, so as presented in Module 1, in grade 7, the students learned to describe motion of objects. And now in grade 8, they will learn the effects of forces on the motion of objects. Also in grade 7, they also learned the different ways by which energy be transferred. So now in grade 8, they will learn that doing work is one way of transferring energy. But in identifying if work is done, they use the concept of force which they learn in Module 1. The module starts with the definition of work. So the key questions are, what is work? What is energy? How are work, power, and energy related? These are the learning competencies, differentiates layman's definition of work from mechanical work, describes how work is related to power and energy, differentiates potential and kinetic energy, relates the speed and position of object to the amount of energy possessed by a body. So the module starts with the definition of work. Ask your student what comes to their mind when they hear the word work. By asking them, you are eliciting ideas on what they already know about the topic. Most probably, students think of work as a job or an occupation. This is usually the layman's definition of work because in Filipino, work is trabaho. And we usually say, ano ang trabaho mo or saan ka nagtatrabaho, which pertains to one's profession or job. If you look at the curriculum, this is the first time the students will come across this topic. They are more familiar with energy because in grade 6 and 7, they were already introduced with the different forms of energy. Oftentimes, when a student is asked, what is energy? They can readily answer, it is the ability or the capacity to do work. But then again, what they meant of work is job or an occupation. While it is true that when you do work, when you do your job, you expend energy, work or specifically mechanical work has a different meaning in physics. Work is an abstract concept related to energy. Thus, to help students visualize what is meant by work in physics, we included some illustrations. So through the illustrations, the student can learn what is meant by physics. So, situation 1 shows that work is done on the chair because the force exerted by the girl moves the chair in the direction of the force, which in this case is towards the right. Situation 2 shows that no work is done on the wall because the force exerted on it does not make it move. Situation 3 shows no work is done on the tray because the force exerted on it does not make the tray move in the same direction. In other words, the force and the direction of motion are perpendicular to each other. So after the students learn about work, they apply it to different situations. So this is now activity 1. Is there work done? The students will explain if work is done in the situations presented. They identify the one doing the work and the one on which object the work is done. So they do this activity. Calculating work or solving for the work done is also included. So the work done by a force can be calculated by multiplying the amount of force applied to the object to the displacement of the object. In the slide, you can see that we only deal with the force applied horizontally and the force applied upward. But if you look at some book, you can find the equation F is equal to FD cosine theta. We did not include that anymore because trigonometric functions were not yet taught in grade 8. I think it will be in grade 9 in mathematics. So though computations are included in this module, it is just simple multiplication in this case. The student should not be given additional problems to solve, nor there should be more time devoted in problem solving. What is important for the student to learn is the concept of work. Work is done on an object when the force applied to it causes it to cover a distance in the direction of the applied force. Another important idea is that work is a method of transferring energy. As I mentioned earlier in the previous module, in grade 6, the students were already familiar with the different forms of energy. And then in grade 7, they learned that there were different ways by which energy can be transferred. So work is also a means of transferring energy from one object to another. When you push something like pushing a bowling ball, work is done on the ball because the ball moves in the same direction as the force. But then you are not continually pushing the ball until it hits the pins. You just give it an initial push and then it rolls. So something was transferred to the ball, causing it to move. That something is called energy. So please, it is not force that is transferred to the ball, but energy. So the ball gains energy, and a moving ball can do work. So the important ideas here, are when work is done, energy is transferred. When work is done on an object, it gains energy, while the one that do the work loses energy. And that a moving object can do work on anything it hits. Thus, the definition that energy is the ability or the capacity to do work. Now, a moving object has energy because the work done in accelerating that object is equal to the kinetic energy gained by the object. So we call that energy of motion or the energy of a moving object as kinetic energy. How the equation was arrived at was explained in the module. There is also a computation problem related to kinetic energy, but it is also a simple multiplication. The important concept is a moving object has energy. Then, in grade 6, the students learned about the force of gravity. It is the force that the Earth exerts on all objects on its surface and is always directed downward. When an object is lifted from the ground, work is done against the force of gravity. An object gains energy when raised from the ground and loses energy when made to fall. The energy gained or lost by the object is called gravitational potential energy. This energy depends on the mass and the height of the object. Thus, the energy gained or lost by an object is dependent on the reference level. Another type of potential energy is elastic potential energy. When you stretch a rubber band or a spring, you exert force that results in change in length. Thus, work is done on the rubber or spring. So, in the case shown in the slide, when you stretch the bow, it gains potential energy. The important concept is that the work done to stretch a spring or a rubber band a distance is equal to its potential energy. Activity 2 demonstrates how a twisted rubber band is store potential energy. This toy demonstrates transformation of potential and kinetic energy. When the rubber band is twisted by rotating the long barbecue stick, potential energy is stored. Once the stick is let go, the toy will roll, showing that the potential energy is transformed to kinetic energy. There are other toys that operate on this principle. You can ask the students to bring them if they have them and let them explain how the toy operates. Another concept related to work and energy is power. How fast the work is done or how much energy was expended or used is called, in a given time, is called power. In Activity 3, the students will compute for the energy expended in climbing a flight of stairs. Then they can compute for their power rating. At the end of the module, these are the concepts that they will learn. Work is done on an object when the force applied to it causes it to cover a distance in the direction of the applied force. Work is one way of transferring energy. When work is done by an object, it loses energy. When work is done on an object, it gains energy. The energy of an object enables it to do work. Kinetic energy is possessed by a moving object, while potential energy is possessed by an object due to its position from a level. An object that is stretched or compressed or twisted possesses elastic potential energy. And lastly, power is the rate of doing work or the rate of using energy. Thank you.
And thank you once again, May. That's the presentation for Module 2 on work and energy. I think our bio teachers have learned a lot about the physical concepts of work and energy through the detailed presentation that was shared to us by May. Okay, again, everybody, let's thank May. And we move on to the next presentation. And may I introduce our third resource person, Mr. Rolando Tan. We call him Rolly. Rolly is also a science education specialist here at UP NISMED's elementary science group. He is a graduate of the Bachelor of Science in Public Health from the University of the Philippines in Manila and was involved in laboratory-based biomedical research as a research staff. As I load Rolly's presentation, I will also mention that he is also a licensed teacher and has taught in the Southeastern College High School Department, in Makati Hope Christian School, and St. Stephen's High School as a high school science teacher, as well as a Quiz Bee coach. Nanalo ba, Rolly, ang iyong mga kinoach na mga estudyante? I hope so.
Yes, ma'am.
He joined
Yes, ma'am.
NISMED in 2009 and is currently involved in projects like the K-12 science curriculum, collaborative lesson research and development, and online curriculum materials development. For his share of the webinar presentations, Rolly will walk us through Module 4 on electricity. All right, we're getting ready
Good
with
afternoon. Good afternoon, and I'm gonna discuss Module 4, which is entitled Electricity. Okay, so this is where the learners are coming from. So I will discuss the transition from grade 3 to grade 6. Okay, so in grade 3, students observe what electricity can do. So like observing how electrical appliances work, when they're being turned on. While in grade 4, electricity, there will be no discussion on electricity as the other forms of energy like light, heat, and sound and how they propagate are discussed. Reason for this is that the flow of charges in electricity may be too difficult for the students to understand at this level. In grade 5, they will understand that materials differ in the way they conduct electricity and see the association of electricity and magnetism in electromagnets. In grade 6, they will understand that it is a form of energy called electrical energy and that it can be transferred or transformed from one form to another. So I will discuss now the transition from grade 7 to grade 10. As they go up to grade 7, there will be a deeper understanding of electricity as the concept of charges will be discussed, including the interaction of these charges. At the end of grade 7, students will already have a concept of a simple circuit and be able to explain that electrical energy is carried by moving charges. At grade 8, they will be dealing more about the current, voltage, and resistance in electric circuits, including safety in the use of electricity. As they go to grade 9, they will be discussing how electricity is transmitted from the power plants to the communities at the macro level. And then finally, at grade 10, a more detailed discussion on how electric motors, generators, and transformers work, especially what happens inside generators and motors, using again the concept of electricity and magnetism. So by the end of grade 7, the students should be able to answer the question, how do charges carry energy? And when they reach grade 8, they should be ready to answer the question, what are the factors affecting the amount of current in a circuit? Okay, previously, in grade 7, no, they should have already learned these ideas. Energy exists in different forms. Energy can be transferred from one place to another. And also, electrical energy is carried through the movement of charges. So here are some of the competencies in grade 8 under electricity. They are actually found in the curriculum guide, and some the activities in this that I'm gonna discuss will stress certain competencies that are deemed important, like infers the relationship between current and charge, investigates the effect of using one or two batteries to various ways of connecting two light bulbs, and explain the functions of circuit breakers, fuses, earthing, double insulation, and other safety devices at home. Okay, for Module 4, these are the two key questions. So how do voltage and resistance affect electric current? And what are the safety precautions needed in using electricity? So, of course, in Module 4, you have to introduce certain concepts like current. So the students will be introduced to this concept as the measure of charges passing through a cross-section of a conductor in a given time. So a device called the ammeter is shown. To connect it properly, you consider that the positive terminal of the ammeter is connected to the positive terminal of the battery, while the negative terminal of the battery is connected to the negative terminal of the ammeter. Because it measures the flowing charges in the circuit, the ammeter must be a part of the circuit to be able to measure it. The unit for measuring the current is amperes. Okay. Of course, the students should also be introduced to the concept of voltage as the work done on the charge, and it is measured by a voltmeter. Unlike the ammeter, the voltmeter is connected parallel to the load, which is the bulb, to be able to measure the voltage across the bulb. Notice also that the positive terminal of the bulb, the voltmeter, and the dry cell, the positive terminal of the voltmeter as well as the positive terminal of the dry cell must be all connected together. And the negative terminal of the bulb, the negative terminal of the dry cell, and the negative terminal of the voltmeter are also connected together. So the unit for measuring voltage is in volts. So for activity 1, this activity deals with the relationship between current and voltage. The students will measure the current and the voltage using ammeters and voltmeters. The top left picture shows the ammeter measuring the current when one dry cell is used, while the bottom left picture shows the voltage drop across the bulb being measured by the voltmeter using only one dry cell. In the top right picture shows the ammeter measuring the current when two dry cells are used, while the bottom right shows the voltage drop measured when two dry cells are in the circuit. So the students will get the readings from the ammeters and voltmeters and present the data in a table as shown. They will therefore make a conclusion that increasing the voltage leads to an increase in the amount of current. The second activity deals with the relationship between current and resistance. For the setups, take note that the voltage must remain constant and therefore the number of batteries should remain the same. The number of bulbs is increased instead, and current is measured as seen on the three pictures. Even if the resistance is not measured quantitatively in this activity, the addition of bulbs, which actually act as resistors, will be able to increase the resistance in the circuit. So, just like in activity 1, the students gather their readings from the ammeter and present it in a table as shown. They will be able to conclude that as the resistance increases, the current decreases. Take note that this relationship is best demonstrated if the circuit connection is in series. Okay. For the third activity, okay, so It deals with how current is affected by the way the resistors are connected. So instead of telling the students to construct a series circuit, the students were asked to connect the two bulbs so that when one bulb is unscrewed, the other bulb goes off. For parallel circuits, students were asked to connect the two bulbs so that when one is unscrewed, the other bulb still lights up. They will make comparisons on the brightness of bulbs and make inferences on the amount of current based on their brightness. They will also measure the voltage drop across the bulbs and realize that the total voltage is distributed among the bulbs in series, while the total voltage is equal for each bulb when connected in parallel. They will also realize that there is only one common path for the current in series and two or more independent paths for parallel circuits, and this explains what happens to the bulbs when one bulb is screwed. The fourth activity deals with how accidents relating to misuse of electricity happen. This is when the teacher can make safety precautions relevant as students see what happens before accidents like electrical fires. Okay. The activity shown is about how increasing the current can make the wires hotter. The orange lines that you see there is the very thin copper wire, and a small white candle is placed on top of it. The copper wire is attached to two dry cells, and the current is made to pass through the wire. As the current passes through the wire becomes hotter and the candle melts. How deep the wires are embedded in the candle depends on how hot the wires are. But in this activity, the current is made to increase by increasing the voltage as shown by the number of batteries used. This is not the case in the household wirings. Household wirings are connected in parallel, and increasing the number of appliances used would lead to an increase in the current passing through the wires. So the teacher must remind the students that the activity was only aimed at what happens to the temperature of the wires when the current increases. So after the students realize that increasing the number of appliances leads to an increase in current, they can understand from the activity the effect of current on the temperature of the wires and be able to relate it to electrical fires. Usually due to overloading of circuits. Okay, so the next task in the same activity is about short circuits. So the task is actually a simulation of a short circuit. Here, the exposed wires are made to touch each other, causing a short circuit and bypassing the bulb so that the bulb goes off. Since the current prefers to flow where there is less resistance, it will not pass to the bulb anymore. So the low resistance of the short circuit would lead to an increase in current. So this is taking it from the second activity on current and resistance. And the large current would lead to an increase in the temperature of the wire. So taking it also from the earlier task of activity 4. Students will be able to infer the amount of current passing through in a short circuit and relate it to electrical fires. Okay, so these are some of the reminders when doing these activities. So students should refrain from playing around to ensure safety while the activity is being done. If the setups have no switch, the teacher should remind the students to disconnect it right away after using it. And if ever there is a switch, they have to switch it off immediately also after using. Okay, to sum it all up, these are some of the ideas that they should have learned after doing all these activities. So current increases when the voltage is increased. Current decreases when the resistance is increased. The amount of current is affected by the way the loads are connected, and overloading of circuits and also short circuits could cause or start an electrical fire. Thank you.
Okay, thank you also, Rolly, for that interesting presentations on interesting activities about electricity. I particularly like the last one about safety activities that teach our students how to be safe with electricity. Again, maraming salamat sa lahat ng mga bagong dating, no? Kahit yung mga bagong dating. We have taken up an overview of grade 8 science, as well as an overview of Unit 1, or that's for your first grading period. And we have taken up walkthroughs of modules 1, 2, and 4. Hopefully, we will have time to do the remaining modules in Unit 1, modules 3, 5, and 6 next month. So we will keep you posted when we get our schedules fixed for these remaining modules in Unit 1. Okay, so it is now time for Mike to share with us some insights on teachers, biology teachers teaching physics, or what biology teachers need to think of when a subject such as physics is placed in their load. Incidentally, as I've introduced earlier, Rolly is actually a bio person. No? He's a biology teacher with he's a background in biology. And parang madali lang sa kanya yung pag-explain sa atin ng electricity. I hope our teachers will have the same confidence, the bio teachers especially. No? Let's have Mike share with us some of his musings about the connection between physics and biology, and how biology teachers should in fact look at teaching of physics. Mike?
And good afternoon to everyone. Science in the old curriculum, as we all know, used to be discipline-based. And the only time all of these disciplines come together is during the integrated science subject of what was then called first-year high school. But even so, integrated science at that time was taught as if the disciplines, biology, chemistry, earth science, and physics, were fragmentary components of knowledge. Second-year high school science deals with biology and hence is handled mostly by biology teachers. Third-year science is chemistry and is handled mostly by chemistry teachers, and fourth-year physics by physics teachers. Science in the new K-12 curriculum will be integrated from grades 3 to 10. In last year's implementation of grade 7, the new science, that's in quotation marks, is not much different from the old science in that both are integrated science. Teachers who taught the subject are mostly general science majors. This year's implementation of grade 8 is different. Grade 8, which was then called second year, deals with integrated science and is handled mostly by biology teachers. So how does a bio teacher come to terms with this new arrangement? This webinar covers the first unit of grade 8 and is focused on physics. How does a biology teacher come to terms with teaching physics? The stereotype, of course, is that every physicist is at heart a mathematician and that every biologist is at heart a chemist. So where lies the rainbow trail between biology and physics? In 1953, the disciplines of physics and biology found a common ground with the discovery of the structure of the DNA molecule. The DNA double helix mystery was solved using X-ray diffraction, which was then a relatively new technique and was mostly used by physicists in working out physics experiments. Since then, more and more physicists migrated to and worked on this interface. For example, developments in the science of optics, which were mostly pioneered by physicists, paved the way for the development of microscopes and of microscopy. Now, biologists use these instruments to probe submicroscopic structures and properties of living things. The interface between physics and biology was brought about, or has brought about, new perspectives on photosynthesis and respiration, osmosis and diffusion, nerve impulses and neural networks, and the long list goes on. As a bio teacher, how do you see physics concepts and principles to be of help to you in teaching not just physics, but biology, chemistry, and earth science as well? I hope we'd be able to continue our conversations and sharing about the curriculum and the modules through our KaSaMa Teachers online community. Ma'am Celia, that's all. Thank you so much.
Yes. Yes. Thank you, Mike. Thank you. Lovely presentation on the interface among subject areas, specifically physics and biology. Siguro naman, hindi na natatakot yung mga bio teachers natin, ano, para ituro itong Unit 1 on force, motion, and energy. At this point, let us move on quickly to the question and answer. I have so far here only 2 questions. And maybe we don't have time for many more, but you can type in your questions and we will try to get them answered in KaSaMa Teachers through our discussion threads in grade 8, about grade 8 science. The first question is from Kristen May Torres of Olongapo City. Saan nga ba? Columban College, Barreto. It's a good thing. How should teachers answer if students ask topics beyond the scope of the grade? Maganda ito, no? Si Dr. Ferido siguro ang uunahin nating sasagutin dito. How should teachers answer if students ask topics beyond the scope of the grade? Siguro yung current grade, no? For example, if it's grade 8 now, or grade 7 in another class. Dr. Ferido, may we hear from you?
Okay.
On this, ma'am?
Okay. Yeah, this is a common question asked during open forum. Of course, we will not dampen the interest of students by just answering, oh, you will take that up in grade 9. But the teacher should be prepared to explain the concept to the student, but realizing also and emphasizing the prerequisite concepts, because it could be that the students are asking a question that has not been made clear to him or her while it was being taught, or while the student has encountered it. So also another way is to lead them to other resources beyond the modules to elicit interest in the student. Keep in mind that the teacher is not the sole resource of the student, and it is good for the teacher together with the student to study further about the topic or the concept that is being asked by the student. It is not good to answer if the question is not fully understood also by the teacher. It is better for both of them to go through other resources to find out the explanation. Also, one good way is to look at the spiraling of concepts, because in explaining that to the students, they will realize that they will be able to appreciate and learn more about a specific topic in the succeeding grade levels. I think that's how I can answer the question of Ms. Torres.
Christine, yes, Christine May. Thank you, Dr. Ferido. Do we have inputs from May or Rolly, or we move on to the next question? In the interest of time, no?
Okay.
Again, the question here is from the City Schools Division of Dasmariñas. Is it required to do the activities in the performance standard? Could we formulate our own activities for our students? I think ang ibig sabihin nito, yun bang mga activities na handa na sa learners modules ang kailangan nilang gawin, or pwede ba silang gumawa ng sarili nilang o iba pang o gumamit ng iba pang mga activities? Okay, so may we hear from our 3 resource persons, please? how much freedom or autonomy do our teachers have when it comes to selecting or performing the currently prescribed learning activities?
Okay,
Celia, may I answer partly?
Okay, so Dr.
I
Ferido
think
first, and
the
then we'll have
question, yeah. I think the question of City Schools Division of Las Marinas is specifically on the performance standard, which is in the curriculum guide. There's a content standard, performance standard, and learning competencies. It's the second to the last column of the curriculum guide. The performance standard as set by DepEd refers to output or performance. I mean, a product or a specific performance related to the content standard. So this is a gauge in assessing how far the students will be able to really perform or create a product out of learning the concepts. I think it may not refer, his question or her question is not referring to the activities in the module. It
Okay.
is specifically focused on the performance standard. I don't see any problem if they make their own assessment in terms of performance. But these performance standards are written in the guide in sync, or this has been given so that the students can be assessed how far they can apply the content standards. Okay, so that's how I answer the question.
Yeah, so really referring to the performance standards, activities that students are required towards the end or midway of the different
Usually this is,
units.
yeah.
I think
These
it is
are
at the end of the
explicit.
unit. Module for each topic, Celia.
Yeah, okay. So I hope our teachers from the division of Dasmariñas City are guided as to their decisions about the performance standards and the activities that are prescribed in the curriculum guide insofar as the standards for performance of specific content areas and competencies are concerned. So maraming salamat again. We would like to thank our resource persons, Dr. Ferido, May Chavez, Rolly Tan, and also Mike Mantala. So ladies and gentlemen, you can click on that status icon, the guy with the raised hand, and look for the applause icon and say thank you to our presenters this afternoon. Okay, so again, I'd like to thank everyone for joining us. We're really running out of time, but I'd like to make some few announcements and request you folks to please provide us with your feedback. We need them. So let me show a new slide and show you as well the link to the feedback for today's webinar. Okay, let me show that closing slide. And we're also going to, aside from requesting you to please fill out the feedback form, we are also going to show you give you some announcements about events at NISMED. We are going to have a conference in October, And we also have new resources in KaSaMa Teachers. And let's just wait a little bit for the slide to show. So you'll get the link to the feedback form. Right, so we really appreciate that you provide us the feedback to your attendance or participation in today's webinar. Kindly click the link, the one in blue text. That's not a very hard to complete form. So madali lang po yung survey na yan. So kindly click on this link for your feedback. And again, we will put this link in KaSaMa Teachers so that those of you who come as a team, as a group, can have the chance to give us your feedback. No? So kasi isa lang yung connection ninyo, mahirap gumawa ng sumagot ng feedback sa isang na computer. So we will give you this link again. We will send it out to you through the emails you have indicated in the attendance sheet or the attendance form. So we get your feedback about today's webinar. Maraming salamat sa lahat, no? I hope you got that link. So please click on that link. And let me take this chance to advertise an upcoming event at NISMED. We are doing a national conference in science and mathematics education this coming October. Our theme is empowering teachers once again for the 8-12 curriculum and using lesson study. There's a lot that we all need to know about lesson study and what prospects it provides for our schools in terms of professional development of our teachers. The fee is 5,500. That's until August 15 for early birds like you. But the regular rate is 6,000 after August 15. And then also we have new resources about K-12 in KaSaMa Teachers. We have provided the link to the Science Curriculum Guide, the April 25, 2013 version. That's the latest. And you can also download the grade 7 learners material and request a copy of the teacher's guide. We also provided the links found in the DepEd's Learning Resource Management and Development System database for grade science. And I'm happy to inform everyone that the DepEd Secretary just today approved or sent the letter approving our request to post grade 7 and 8 resources in both science and mathematics. O, diba? So you can come again, visit KaSaMa Teachers, and we will provide you the links to those resources as soon as we get them. Ang maganda lang nun, meron na tayong permission to post these in KaSaMa Teachers. So immediately, maybe in a while, we will be posting the link to your request for grade 8 Science Teacher's Guide. And we have also compiled for you a list of the latest DepEd memos and DepEd orders, and we have created the download links to them again in KaSaMa Teachers. So maraming salamat everyone. I hope you've filled out the feedback form. We will put them up again in the chat window, so it will be easy for you to click the link. We hope to have the next webinar as early as July 11. We will let you know. We will again broadcast invites through your KaSaMa Teachers membership account. And then we will also contact those of you who are not yet in KaSaMa Teachers through your emails and your probably your schools out today's attendance sheet. So we will let you know. The earliest is July 11. Otherwise, again, the 4th Friday of July. We'd like to catch up Unit 1 for for modules 3, 5, and 6. So, gusto na mid-July na sa inyo itong webinar na ito so that you will have until the middle of August for the first grading period. So that should answer Ma'am Deville. The registration fee for the national conference include accommodation. Let me flash that. Registration only, meals, conference kit, and a book on lesson study. You have to reserve separately for the accommodation. Okay, so please remember, our webinars take place on the 4th Friday of the month. Minsan yung 4th na yun nasa last, minsan hindi rin kasi minsan may 5th Friday pa, no? But it's just the 4th Friday, and at 4, log in as early as 3:40 or 3:45 so you can test your audio and your internet connection. Maraming salamat sa lahat ng mga umattend ngayon. To the Cavite teachers, to the teachers of the City Schools Division of Dasmariñas, Don Bosco Technical Institute in Makati, and all our returning attendees, and our first-timer to the UP NISMED webinars. Maraming salamat po, and hope to see you again July 11 for the continuation or part 2 of Unit 1 on Force, Motion, and Energy. Thank you very much, everyone.